This video is going to demonstrate how to set up ray tracing in a Unity project. If you are a student in SGD113, I highly suggest that you follow along and keep this project so you can refer back to it as reference for setting up ray tracing in other projects. I have a starter scene ready to go, and I'm not going to demonstrate how to set this up, but I will talk about what is in here so you could pause this video and take a moment to set this up in a similar way. I have a main camera, and with this main camera, you need to double check that the tag on your main camera is actually set to main camera. It seems like sometimes that this will be set to untagged, but do make sure it is set to main camera, or else the ray tracing is not going to work the way that we set it up. If you find your ray tracing not working, this is one of the main culprits, is that you forgot to change the tag on the camera to main camera. We also just have a plane in our scene as a ground plane. It doesn't really matter what you do for this. This is just to have another object in the scene to show that clicking on it eventually will not do anything. And we have a single cube object. This cube object, you do need to make sure that you are tagging this as something else other than untagged. Give it a unique tag. For this, I'm just going to tag it as cube. I am using a capital C. You can tag this whatever you want. Just make sure that you are remembering what you tag it as, because we're going to need that when we get to our programming. Double check that this is set to tagged as cube. This is another spot where you might find, if you find your ray tracing not working, you probably forgot to tag your cube, or you might have misspelled what you ended up tagging that in your code. So double check and remember what you tag this as. The last thing we have in here is our game controller. This is just an empty game object named game controller. Since this is usually how we do our projects in our class, I figured we might as well do the demo the same way so that you know how and where to put this. I also have a game controller script named game controller that is attached to this game controller object. And inside the script, I am just starting off with nothing in here. We actually don't need anything in our start. If you do just want to delete out your start event, that's fine, because we're just going to be doing everything inside of our update. This is going to be a very simple program. All that's going to happen is when you hit play, if you click on the cube, we're going to destroy the cube. If you click anywhere else in the scene, it's not going to do anything. This is a great example to show how ray tracing works. You could use this in a lot of ways. This is how you would possibly set up a gun in a game to shoot an enemy, or to click on objects and have events happen. So you're going to use this quite a bit as you make stuff in Unity. So that's why I suggest you do this, save it, and you can reuse this code in other projects as long as you manipulate it in a way to fit the project that you're doing. So pause the video here if you haven't set it up, and give some time to set it up. And when we get back, we are going to start in here. So the first thing that we do need to do in here is we need to check in our Actually, you know what? We're going to write this as a function, because we really should not put all of this code inside of our update. We should keep the update kind of clean. It's just a good habit to get into, that we shouldn't see a big block of code in our update. So we're just going to write a void returning function, and we'll just put it in here for now, and then we'll write it underneath. So we're going to call this one check for clicks, and we're not going to pass anything to it. So that every single time the game updates, we're going to check to see if the left mouse button was clicked. So underneath here, we can just keep this as a private, because we don't want to access it outside of our script. So we're going to write private void check for clicks. And if you want to write a little comment to yourself, because it's good to comment your code of what this does, either above or below it. I should probably put it above it just to keep it clean. This function checks to see if the left mouse button was clicked. If it was, it checks to to see what it was clicked on. Good enough for now. I'm going to be putting comments in the rest of the code as we go so that it makes sense of what we're putting in here, since this is for reference and you want to 100% understand what all of this means if you have to come back to it. So the first thing we need to do in here is we do need to check to see if we have a mouse button click or not. And you should have done some input events by now. Inside of the Rollerball game, we did do an input check to see if any WASD keys were clicked, but you haven't done anything with mouse button clicks. And this is a good chance to kind of practice using the Unity API. So we know that we're going to have an input event. So if we navigate to the Unity API, it's just, if you Google search for Unity API, you should get to this page. And if we search in our scripting for input, because we know it's going to be some kind of input, it's going to be a mouse button click. So let's see what options we have for us. So we'll give it a second. And we can see that input, we have the first one right here should work to see what kind of inputs we can use. And we can read a little bit about it, but we're mostly looking for the methods. What can input do? That's, methods, functions are kind of, for our purposes, interchangeable words. So these are things that input can do. And we've used this get key for the WASD, but that's not what we want to do. We want to do a mouse button. And if we look down here, we actually have three choices. We have get mouse button down, and get mouse button up. And we can read a description about this. So if you are thinking about which one we should use, you might initially think that we should use this get mouse button down because we're looking for a left mouse button click. But from experience, trust me on this one, you do not want to actually use this if we're looking for a singular click. The reason is we are calling this in our update. And if you remember, update is called once per frame, and our game is probably going to be running most likely at 60 frames a second. I don't think you can click your mouse button fast enough for 1/60th of a second. So if we use get mouse button down, we're going to get a lot of true hits because it's going to keep showing that we have our mouse button down, which might be some kind of behavior that you want, but for our purposes, get mouse button up is going to work better because this is only going to return true on the frame that we release our finger from the mouse button. So we're going to click on get mouse button up to get some more information about this. So let's see. They have a description about it, but the one nice thing about the Unity API is they usually do show explanations about how to use their methods. So if we look here, it's using it in an if statement where if input.getMouseButtonUp and we're sending it is a 0, it'll print to the debug log that the left mouse button was clicked. 1 shows the right click and 2 shows the middle click. So we're looking for a left mouse button click, so we can just copy this right from the API. We highlight it, right click, and copy it, go back to our code, and we can just Control V to paste this in, and we have the code in here for us. We can even take a second to just double check that this does work. Since this is printing to the console, if we left mouse click anywhere in the game, we could quickly save this. What's it complaining about? Hold on. Where does it want that? That's weird. Oh, I see. Missing a curly brace. There we go. So let's save this. Go back to Unity. I already have this attached to my game controller. So if I hit play, I should be able to click anywhere inside the game. Don't accidentally click inside your scene. Make sure you're clicking inside your game or this won't register. But I'm going to go make sure my console is on. I'm going to hit play. And if I click inside the game, you can see I'm getting that debug inside of there. If I right click, nothing happens. If I middle click, nothing happens. But left click, I do get that message. So I know that it is responding, that I am getting my left mouse button clicks. It's always good practice to check that your code is working as you go. Don't type this all in and assume that it's going to work, because you might have little problems here and there. And if you have little problems throughout the whole thing, it's going to be a lot harder to figure out what's going wrong when you have multiple problems rather than just a small problem in one little spot. So this is good. We have our mouse button going. So we can even leave a little note saying, this is how you check for a left mouse button click, so that you can remember what this does. So next we actually have to do our raycasting. We're finally to that point. Raycasting has two main parts to it. We need to create an object of the ray itself, and you can think of this either as I guess the way I like to think of it is, think of it as a laser pointer being held on your forehead, and you're looking around, and the actual beam of the laser is the ray that we're going to cast. And we also have to create an object to hold the information about what that ray hit. So again, think of it as you're looking around your room with the laser pointer on your head, and whatever that laser ends up running into, like a chair or the wall or the floor, we want to be able to hold that information so we can take a look at it and see what it is. So the first thing we need to do is we need to declare a ray object, and we do that by, it's just called ray. This particular ray, I'm just going to name it as ray. And in order to set this up as a ray, we want to set this up so that it's a ray that is shot from the main camera in the direction of wherever the mouse is on the screen. And to do that, it's just this code. It's camera.main.screen to point ray, and inside the parentheses you put input.mouse position. And I'm going to leave a little comment on what this is, and I do suggest that you might want to leave this in here too, just so you remember what this is all about. This is just a ray from the camera into the mouse's position. So at this point, it's just a straight line that goes on forever from the camera to the mouse, so that when we're in our game, wherever the main camera is, and because this is going to be like the player's viewpoint, to wherever your mouse is on the screen, it just goes in that direction. So you can, again, think of it as a laser pointer in your head, and you're just kind of looking around a 3D environment. So we got our array, and now we need to declare an object that's going to hold the information about whatever object that we run into. And this is just called a raycast hit object. So we write raycast hit, and I'm just going to call this hit. And that's it. We can't put anything in here yet because we haven't actually done our raycasting yet. But I will leave a little comment on what this is. This, oops, sorry, that's the wrong code. This is going to store what is hit. So we have array, we have something to hold what is hit. So now we can actually check to see, we can actually do our raycasting and see what we're running into. So this is going to be an if statement, and I'm going to type out this code, and after I type it out, I'll explain what this all means. So just bear with me for a second. We're going to do it as an if statement because we want to make sure that we hit something. Because if we click off into space and we never hit anything, we don't really have to worry about what's inside of here. So if physics dot raycast, and inside the parentheses we're going to send to it the ray, and we need to send to it that hit object, but we're not just going to write hit. We have to write out hit, and I'll explain why in a minute. And then we're just going to do 100.0f. That's just a float number of 100. So what does this all mean? This is kind of like the big important part of the raycasting, because this is actually where we are looking at where was clicked into space. And I'm going to just drop in some code. Drop in some comments, and I will explain what this whole thing means. So this is where we're looking at the raycast. It is looking along the ray, which is this thing right here. And we have it set up as from the camera to the mouse's position for the length of 100 units. And that's what this 100.0f, this is just a float. This number is kind of arbitrary. All this says is keep looking until you either hit something or you go this far. So just make it some number that would be long enough that you would eventually either hit something or you'd be pretty much outside of the game field. So like you wouldn't want to set this to 1 unit because that's going to be way too close. That, you know, you most likely would be missing things that you actually are clicking on. But you wouldn't really want to make this 1,000,000 because that'd be way too far. This is, you just have to kind of judge, but usually 100 units is a decent amount. So if in another game, if you have like a much larger environment, if you're finding you're having raycasting issues, you might just need to make this number a little bit bigger. And what this out means, and we haven't really covered this yet, and honestly, this might be the only time in this class that we're ever going to use this out. Notice it's blue because this is a special C# keyword. What this means is normally we pass our parameters by value, where we just send it what's being stored in there, like the information about it, but not the actual variable itself. This though means that this hit object is being passed by reference. So when we send it to this method, it's going to make alterations to this parameter inside of the method, and this will store back inside of this object here, because normally that doesn't happen. This ray right here, since it's being passed by value, we could make changes to this ray inside of, like the raycast can make changes to it, but this ray here would stay the same. It wouldn't change. But since we put this out keyword next to hit, this is going to have information written to it. It's actually going to start storing what gets hit. This is how you get that information into there. So if you're having issues with your raycast working, make sure that you did put out next to your raycast hit object, or else this won't work correctly. And let's see. So this works that if the raycast hits something, it's going to store that into here. If it doesn't hit anything, we don't really care because we don't need any kind of interaction. So next we just need to code what happens if we hit something. And this should just be kind of review if you've done Rollerball. If you remember from Rollerball, we did, we would have the ball run into the pickup objects, and we would need it to check to see if we were running into a pickup object or not, because you wouldn't want the same kind of interaction to happen if you hit like the wall or the floor. So this should just be kind of review. So we're going to write if hit, which is this object here, it's whatever we clicked on because we got that from doing this. If hit.collider.tag is equal to, and I did a capital C cube. This is whatever you remember we created that new tag for the cube inside Unity. If you don't remember, go back and double check that it's the same right here, because it's checking to see if it has that tag. And if it has that tag, we can do something to it. And don't forget, this is a double equal sign because this is to check if it's cube, not set it to cube. So if you also have mistakes, double check you didn't accidentally set it to 1. Make sure there's that double one there. So what are we going to do? We want to destroy that cube, and we can just do that by doing destroy. And inside the parentheses, whatever we hit. So that hit object dot transform dot game object. This should just be a review also from Rollerball of how to destroy an object. If you wanted to have different things happen to different objects in Unity, if you click on them, you could have them set to different tags. So we could have like a cube tag, we could have a sphere tag, we could have a cylinder tag, or maybe one gets destroyed, one changes color, and one bounces up. You would just make another if statement under here looking for the different tag. So let me add some comments here just so that we know what this is. We are looking at what we clicked on to see if it has a collider or not. And if it does, is the object tagged as cube, which is the custom tag we set up in Unity specifically on the cube prefab. And then we are just destroying it. And if you want to just be a completionist, we can leave a little comment here. This is the code to destroy the object clicked on. That's all that is. And we should be pretty good to go. This should be it. So let's save it. Hop back into Unity. And let's play it and see. So remember, you do have to click inside of the game in order for this to work. Don't accidentally click on your cube inside of the scene window if you do have that as like a separate window, because this won't function. So I'm clicking in the sky, nothing happens. I click on the ground, nothing happens. Even though it does have a collider, it's not tagged as a cube. So if I click on the cube, it disappears because we destroyed it. And we do know that it was fully destroyed because it did disappear out of our hierarchy. So we know it was destroyed, it wasn't just hidden. If I hit start, or if I unplay it, cube does reappear. Might as well double check. So keeping on that cube there, and it's gone. So that's it. That's the basics of raycasting. Like I said, I suggest you follow along with this and get this functioning for yourself, because you can just save this project. This is what I recommend. Save this project and keep it with you. So if you ever have to do ray tracing again, you can refer back to this. You could even, if you need like a click event, you could just come in and copy and paste this code and put it in your new project if you really needed it. Just make some alterations. Like maybe you're not looking for a mouse button click. Maybe you're looking for some other kind of input. Maybe you don't want to hit a cube. Maybe you have other tags, and maybe you don't want to destroy. You want something else to happen. This is going to be very useful code for you. So make sure you're getting this working. Hopefully you found this useful. And if you have any questions, refer to the Unity API, and there are a lot of tutorials done by Unity itself with doing raycasting. So hopefully you found this to be useful.